Hello and welcome back to this action object tutorial in Unreal Engine. I'm Thomas M, and today I'm actually just going to give you a sneak peek at something that I've been working on with this action object system that we built in the tutorial series. It's been about a week. I've spent about 3 days working on this, just building out a little bit more functionality, adding a little bit more to it. So now when we play the game, you can see that we have some bad guys that take swings at me. I've got some hit reactions, I've got some VFX playing when we hit them. I've got multiple abilities. I've got this shout ability here that throws fire, and when they don't die, they knock back. Like that. I've got a double jump, which is now actually just built into Unreal, which is pretty cool. So yeah, I've added, and I've got an evade that actually works too. Get a bad guy. So you can evade through him. So that's pretty cool. And that works with our combos and all that fun stuff. I added a third strike to the combo. And then the shout and the evade. But more than that, I've done quite a bit of restructuring and sort of like how this code works. So I'm going to start by talking about the player a little bit and how he's changed. So the first thing I did, if we open up his actual blueprint, is I took most of everything out of here that we did in the series. We had a side scroll character that had all of our input and all of our tags and all that stuff in it. But now you can see that the side scroller character, I've made a character underscore player class. And then in this class, all I actually do is handle input. And I'm calling the event dispatchers that you probably recognize from the last videos. And I'm, obviously working with tags. I've added crouch, but I haven't actually done anything with it. I'm working on an air to ground, like ground pound kind of thing right now. So you'll see I've got like the event dispatchers are all set up, but I just haven't made an ability to do it yet. I haven't found a good animation actually. But that's all that's in our player. Most of what you saw in the tutorial series is in our base class. So in our base class here, I've done a bunch to clean it up. I actually deleted the debugs out of here. But this Etags thing gets rather big when you try having like print strings that, every time you add a series of tags, like print everything that the player has and things like that. I will note that I had to do some extra work with the Etag system. Originally in the series, I had it as a set, and then I was adding things to the set and removing things from the set. And the problem is that you can only ever have one instance of an enumeration in a set, and every time you say add another one, it just says, well, I already have it, so I'm not going to do that. Every time you say remove, even if you manage to get it to have two, you say remove, and it says, well, I'm going to pull all of them. And that's sort of the default behavior in Unreal of how it sort of manages arrays and big data sets to make sure that you don't add duplicates. The problem is I really want to add duplicates, so I kind of had to do some unorthodox things to do that. You'll notice that adding Etags is now done through appendsion. Whether you add an array or you add a single one, it goes through the append function to make sure that it doesn't actually compare any data inside of the array before it just adds the new tag to it, so that we can have multiple instances of the same tag. And then for removal, we have to actually, I did a do once that gets reopened by a sequence and a for each loop that gets broken to really make sure that we only remove one index, because it really wants to remove all of them, or at least two. Like if you have two tags right next to each other, it came into some problems of like removing both of them every once in a while instead of only one. So this way, when we call remove, we definitely only remove one. And then the other thing I did in here is I actually did our attack colliders. I just created an interface, I melee attacker. And in this interface, I have a function set collider active, and it takes in a boolean, a collider ID, which is just another enumeration that I made really quick. I've made a few enumerations just to make my life a little bit easier, because I don't like saying 0 is right hand, 1 is left hand. I like actually seeing right hand, left hand, even though they are just 0 and 1. So just create this little enumeration here. Then I can pass it in through my function, as well as the attack object, similar to how we did the fire functions, which I don't know if we actually got to that in the tutorial series. Attack colliders. Every class has every class that derives from this class has to set up their attack colliders. So like our player, I added the 2 attack colliders on their hands right here. If I toggle them on, you can see them. They're just 2 regular old sphere colliders, and I just make them invisible for now. It's important to note that you have to have them generate overlap events in this menu and then turn them off actually in the constructor. So in the construction script, I add them to this attack colliders array that was in my base class, and then I tell them to not overlap, or to not generate overlap events. Now this means that they will actually be able to generate overlap events when they turn on, but for some reason if you change this in the editor, you'll often run into problems where like if you set this to false and then you turn it on at some point during the game, it just won't actually generate overlap events. It doesn't get added to whatever library it is Unreal builds like at runtime. So anyway, our attack colliders are right here. All we're doing is setting them to generate overlap events. In this interface, we just call out of an action, right? We call out of our attack actions, and we'll get to those in a little bit. So this makes sure that the attack colliders ignore themselves, even though technically the collision layers should actually take care of that with the way that I've set them up. But it's good to make sure that we have something like this, because in the big bad world, things happen. And then we are binding an event to a component begin overlap, and that is damage overlap that lives in our attack object, which derives from action object, and we'll get to that again in a little bit. The other thing I did in here is, no, we definitely did this in the tutorial series, because we bound to primary and secondary, and we tested a little bit with the shout as well, yes. So we have, I've added a couple more input abilities. I added evasion, hit reaction, and in-air primary. Like I said, I haven't actually worked with in-air primary much yet. I've just sort of set it up. Then I decided I needed to make this video, so it's just sort of in here not being used yet. But as you can imagine, on hit react is an event delegate that gets called when you get damaged. So when you get damaged, if your health is not below 0, you do a hit reaction. If it is below 0, then you die. And death is simply a function in the player. That's something that I like to do as a design choice. You could obviously just add a dead tag and then like call a death action if you wanted to, and then the player's action could be like, like fade out the screen and then ask do you want to restart or whatever. But I like to actually put death inside of the character pawn class itself. That way there's no chance of anything ever going wrong with death, because if something doesn't die, it can be really bad. Right, so I haven't implemented player death yet. He doesn't actually die, but our AI characters die. We can see that in side-scroller character AI here, which is just inherits from side-scroll character base, and all it does is die. That's all AI character base does. And then I have a further character class that sets his mesh and gives him colliders. And that would be specific for each enemy type. So this is basic dude, as I called him. You might recognize this model. He's a really commonly used one off the asset store. I've just added an emissive color to his material to make him look a little like cartoony. But yeah, his event graph is empty. In here he's got his attack colliders that he turns off. And then he does not, right, he doesn't die. The AI class dies, but he inherits from the AI class, which inherits from base character. Anyway, damage, I also included knockback, because a lot of stuff I like doing knockback, especially in 2D games. So I haven't like really hammered on it yet, but knockback at least exists here. I haven't really hammered on the values yet, as far as like how it works in Shout, but it's here, it works. And the other thing we do in our character base is we give action objects. In the tutorial series, I talked about how we got the owner-actor reference, and then I decided to create an additional base class to the attack action that we use in the series called montage action. And this is so that my hit reactions and my attacks use the same child class. So, let's see. So you remember from the series, we had action object, and I don't believe any of this has changed. This is pretty much fire and forget. I added a bunch of debugging in here, which is just, I've been blocked, print my owner tags, required tags, block tags. This was just debugging as tags get rolled on and off and things get approved or not approved to fire. The other thing I added is actually can't execute multi. So I built in an isActive tag into this class that gets checked here in can't activate action. The thing is, we only want to check it if we can't execute over ourselves. So can't execute multi is can I execute while I'm already active? I wrote a little tooltip here. That way I can kind of remember too, as I create like child classes of this, that this is what this means. And I also added a valid self check. This just makes sure that this pointer isn't null technically. So yeah, just make sure I sort of am an object. And it's come into play a handful of times, just added some stability. As you can see, my event graph is still empty. So that's really all I've done. Activation required and blocked we got through in combos. And then in the attack base, I was going to montage action, sorry. So in our basic class, we're actually looking for montage action. And all I've done here in BP montage action is I created a bunch of events. So I played the montage by getting the owner skeletal mesh component, is again exposed on spawn, instance editable. So it gets set here when this action is constructed. On give ability, it is an action object, so it's getting bound to input if it is an input ability. Most of these are, but not all. But anyway, every action that plays a montage plays it using this function, play montage at section. And then all this does is fire a bunch of events. And these events are over here. On montage start, completed, interrupted, notify begin, notify end, and blend out. So these are just the default things that spit out of this play montage node pretty much. And the only things that actually do anything are interrupted and completed. For the most part, these need to end actions. The biggest exception, of course, being attacks. Don't always need to interrupt the action, so I sort of override and play around with interrupted quite a bit throughout the pattern, you'll see. The montage completed, I almost always end up calling here and just ending. An instance of our montage actions, seeing this at work, is our attacks. So these are a montage action, so they're already doing montagey things. So in attack base, I added a function called play VFX, where I built some basic functionality to spawn an emitter attached to the skeletal mesh component, and then to detach it from the skeletal mesh. The reason I do it this way is because you can't actually just spawn emitter at location from an object. The other option really is to do it through code and do a step in the middle there where I can create that function. But if you spawn emitter attached, you can do this from an object and then just detach it. And this works exactly as expected. It's probably a little more expensive than doing it the other way, but it's accessible in blueprints, so I did this way. And let's see, I also set the, I get the dot product of the forward vector of the emitter we just attached, because it's attaching to a socket, so this socket is obviously facing whichever direction the player is facing. So then I just get its forward vector, take the dot product of that and the world Y. Because being a 2D game, we have one direction that we face, so it's really handy. I don't have to look for camera right or anything. I can just know it's Y1, which is awesome. It should be camera left, but yeah. So then we determine, are we facing left? And if we are, we set the rotation of that visual effects. So when we play our shout effect, it faces this way, and then when we turn the other way, it faces this way. So the effect actually react. But this can just be overridden in child classes and can be included wherever visual effects are needed. So like in a base attack, visual effects are actually not included. They're not included until we have an instanced attack. And then we override that play VFX, because every attack is different. Like you'll have a hit effect that's like when you actually strike an enemy, and sometimes you also have a running effect, and you might even have a mesh effect as well. So having something that you override in the child classes every time makes sense. I had considered making visual effects a parallel hierarchy of action objects. That's how the gameplay ability system does it, through gameplay cues. You have a totally different set of actions that handle playing the actual cues and playing the effects. But really, I didn't feel like it was necessary for this project, because I can just override some functions. I'm doing quite a bit of blueprint code. I'm not doing a lot in C++. I'm not worried too much about optimization or anything like that. So I'm not super worried about like trickling in my visual effects. I might eat those words in a little bit, but if I was working with a larger team where we had, say, a dedicated visual effects artist, then I would go ahead and definitely give them their own class to play around in, and then it would just attach to essentially these functions. I would just create event dispatchers here that the visual effects could just attach themselves to. So the attack base would just create its visual effects action whenever it's given, and then the visual effects would just attach to the dispatchers in the attack base, the same way that sort of the player character does it, through its fire abilities, but this would be more to the montage events, like bond to montage event sort of thing. As you can imagine, that would be quite a bit of work, so I've decided not to do that for my solo project. Anyway, continuing on with base attacks, I've added the set collider active function that we talked about in the base character class. Again, this is base character, so it's shared by both AI and player. So we're passing in ourself as the attack object. So I'm getting my damage event bound for when these hand colliders overlap enemies. So when they overlap, I'm asking if the ability is active. And this is because sometimes a collider will remain on, or a different attack will turn on the collider and this one will still be on for some reason. It hasn't unbound that event yet, and it might just fire for some reason. It happens just with the order of how things sort of get done. Like if you say die in the middle, it kind of creates some weird behaviors sometimes. So this is one of the ways that I hard compensated for that, is checking, is my ability active before I do any damage? And then I also maintain an array of damaged actors during the attack. You'll notice that on activate action, I clear damaged actors. Okay. So this add and remove tag, don't worry about too much. This is just adding an extra copy of movement blocked, just because in the event of all things going to hell, sometimes movement blocked would get dropped. Like sometimes Unreal has some issues with this pattern as each of these child classes is adding a little bit more functionality and a little bit more to it. Sometimes things fall down, sometimes things don't work perfectly, and it's like 1 out of every 600 times that it does it, it might drop the movement block tag. So because I'm paranoid and because I really like things to be super stable all the time, I added a movement block tag in addition to other stuff that's already being added in the parent functions and in the child classes, and everything that's in my attack active tags are already being added, but I go ahead and do an additional movement block to just, I'm paranoid. So that's the kind of things that I do. You can choose not to do that if you want, and 1 out of every 600 times it might not work for you. So there you go. This damaged actors, again, should really, I don't know if you necessarily need it, but it's something that I find really, really helps. Sometimes you'll overlap something twice in like a single frame or 1 frame right after the next and not necessarily get the initial overlap. And especially if you start doing like continuous collision detection or anything like that, like you will fire this bajillion times. So just to have more, applicable base classes and things, I go ahead and handle an array of damaged actors and make sure that we don't apply damage multiple times. or get credit for damage multiple times, because eventually this will also add a points, right, or a score of some kind. It'll charge my ultimate meter and stuff like that too. And then we ask if this is a player ability, and the only reason that this boolean exists is for camera shakes. And this is whenever I do damage, I'm going to do a camera shake, and I can set that shake in the base classes. I just have one that I use for everything besides the movement shake. That's the only reason we do that, is who do we call the interface on is really it. Because if we're an AI, we don't have this function. It's in the player class. I should just point it out. Get camera shake source component. Just returns the camera shake source component, as you might expect. And it turns out if you just put this on your pawn, sometimes it'll work, but sometimes it won't, or it'll stop working all of a sudden, which was really frustrating. So if you put it as the direct parent of where your camera is between it and the spring arm, it works just fine. Really weird. I guess you could put it above the spring arm too. And then you could move the spring arm but have it but it might be dampered a little bit. I don't know if I like that. Preference, I suppose. Anyway, so back at our attack actions. That's all our damage does, and that is all our attack really does. It takes most of the functionality from being a montage, and it says as the montage does things. I have a couple more things I want to do along the way, and that's about it. And then for an actual attack that gets used, we can take our combo strike. So our combo strike is the first attack in a combo. So I have combo strike, and then I have combo subsequent strike. So combo strike is one that's going to exist all the time. This is never going to destroy itself. It's going to exist by default on our character. So for our default character, we actually have primary first strike. So if we grab that. So this is his actual primary first strike attack. That's not where you look at it here. And as you can see, it's a BP combo strike, not a combo subsequent strike. And the next action we're going to add to it is a secondary strike. And I'm playing the montage at 3 times the rate because these are built for a giant dude and I want him to be really fast. So yeah, so this is how just the first attack is set up. You can see our montage here. We're at attack 1. We're input bound to the primary. We've got some active Etags, we're blocking movement, but it's important to note that we're not blocking evasion, because it's a design choice that while you're attacking, you can just stop what you're doing and just evade. Right. And I also blocked this by having the combo gate open. It's just another way to make sure that it never fires this attack while the next attack is active. I add primary attack active in the subsequent strikes. So combo strike, again, we're just overriding montage stuff and adding a little bit more functionality to it. So when the montage starts, we make sure we don't have our combo gate open tag, and we make sure we don't have a leftover next action. So the next action that we set in here is actually next action combo. So next action combo is a class, and as you might expect, we're going to be constructing that class and passing in our skeletal mesh component and our owner actor, just give it references it doesn't have to cast, but then we're saving it to a reference. And then we're going to try to destroy it as long as it's not active. That's all this function does. So we try to destroy it, and then we set our reference to it to null, because this should actually add it to garbage collection, and this should actually destroy it. But you'll see our end action in a combo strike also attempts to destroy itself. And these subsequent strikes has been overridden. So this is the first strike, and then the second strike and beyond is a subsequent strike, which does a little bit less, but in end action, it makes sure that it gets unbound and destroys itself. And that's really about all it does. And on montage completed, it tries to destroy its next action, because again, a subsequent strike is a combo strike. There's something kind of weird to think about, that the next strikes are different enough that we have to write their own code, but it needs to include everything that the first strike did. But this way it can have continual attacks. So our first strike Like when we hit play, none of these exist. All that exists is our first strike. So we have primary first strike, and then we have it also in our basic dudes, because they use, again, the exact same strikes. And for our player, we have our primary strike, but when we start getting going in the combo, there's actually a 3-hit combo here. First strike, second strike, and third strike. So the second and third are being created dynamically as the game is going, or as the strikes are going. And that is in our first strike or combo strike. Well, I guess in all of them, really. On montage notify end, when we added that tag to open the gate, we instead also construct our attack base, our next action combo. Right, the next thing we want to add on. And then we make sure it gets cleaned up and destroyed. Oh, and here's our VFX function for on damage. That's what calls our effects there. And that's really all this does. And then the subsequent strikes, all it does is, on montage completed, adds a little bit more and says, hey, if the combo gate's open, try to destroy the next action. If we've completed the montage, but and our combo gate is not open, as in we're not firing the next attack, then we try to end the next action that we've created, just in case it exists. And this one's actually a double call, because this is trying to destroy, and then it will ask if it's active, and then we're calling end action on it, which will try to destroy itself. Oop, I don't know why I went all the way to the base class. Yeah, in end action, it will try to destroy itself. So in each one of the actual strikes, all I had to do was set variables. So in our monster class, primary, my second strike, again, adds the third strike. That's my next action combo. This one, don't worry about. This is on the left hand, again, damage. I got FX at a little bit different offset. And that is pretty much it. And then the third strike, all it does is just not have a next action combo. Yep. And I also intentionally wanted to add the evasion blocking this one, because for some reason only this tag has this weird issue where if you evade, sometimes it'll let you go straight to the third attack in the combo, because it doesn't quite get destroyed properly. Not 100% sure why that happens, but yeah, something to think about. Or just something of note that, little stuff like that happens, where it's like, maybe I'll throw an extra tag here or there. That's why we use enumerations and not strings, So these are very lightweight. So next we'll talk a little bit about the AI. As I mentioned, the AI use the same, they use the same actions. So if we look at his first strike and we put it like side by side to the player first strike, monster primary first strike, this is the one that's on my player. So we can see that these are different references, basic dude and monster, for the next attack, and this one is unmarked to player ability. Other than that, the play rate is a little bit slower because I have the AI attacking slower, but other than that, they're pretty much the same. Now, there's really not too much difference in them, other than activation is blocked by being dead on the AI. Like, I've fully integrated being dead on the AI, whereas I haven't quite fully implemented anything for dying on the player. So yeah, the actions themselves are just not player abilities. So the only difference there is that they play camera shakes differently. So the actions themselves, they bind in the same way that normal actions do. They get bound to input when they're given. And when they bind an action in the AI class, it works a little bit differently because there's no input events, right? On our player character, we had input events, right? That's how we got all of our delegates to fire here, was on all of the input actions. Well, we don't have input actions on our AI, so instead, we actually don't have anything in his event graph. The reason is because all of his decision making is done by his AI controller. So I'm going to grab his AI controller. I'm going to pop it over here. So here we have a little bit more stuff. But again, these are really, really simple AI, so there's not a whole lot going on here. We have on begin play, I'm doing a timer for update location. I posted a thing on my Twitter actually where I was running a bunch of performance testing, and this is most of what I was testing was, do I put this function on tick or on a timer? It turns out a timer with an initial start delay variance, just in case you spawn a bunch of them in the same frame. This is definitely the most optimized way to do it as far as, you know, what my performance testing has brought out. Like, I know tick is an optimized function, but running a timer with a short window is much, much cheaper because you're just not running it as often. And especially if you start adding your AI at random points throughout the game, or like spawning them in times based on even other events that aren't necessarily on the frame rate with the rest of the AI, right? So that's where you really start to get some cheapness, get some optimized performance. So all I'm doing here is I'm running an update location function, and so this is asking if I'm moving or not, and then I'm asking if it's blocked, and I actually shoehorned in a quick fix here that I should just make into a function. So if movement is blocked, then we're already running an attack. It's kind of maybe not the best pattern, but for right now, since they do so little, all they do is they move and attack. So it says if my movement's blocked, I'm probably attacking, go ahead and swing. And then the swing will determine if, like, hey, I'm blocked by something else, or like I can't swing for whatever reason. So this just sort of, this isn't the end all be all to I'm going to swing every single time. But if we're not moving, can move, then we're gonna look for the player. And I do this by constructing a targeting object. This is another little bit that I had to write in C++. I'm sorry. I tried to get around C++ as much as I could for this project. But I can show you what this looks like, this targeting object. This is really more of a multiplayer pattern, but I like to use it for my single player stuff too, just because I do not like writing line trace and sphere trace and do all of this, you know, tracing and stuff. I don't like writing those functions 50 million times every project. It gets kind of tedious, so I like writing it in one spot and never dealing with it ever again. So that's why I have this targeting class object here. So all this does, if we look at our header file, we've got a couple of enumerations, or you have an enumeration. This is ami-spherecast or raycast. If it's really, you know, one or the other, it could be a bool, who cares, but it works. It gives me a drop down. And then I have a target struct, which is just a ustruct that I can blueprint. And you'll see it. Yeah, and you'll see it. Here's the target struct. Since it's blueprintable, I can just make it here and have this menu here. This is all the stuff that's in it. Owning actor, starting any position, sphere radius, object type. So this actor class filter, I had to promote to a variable in my AI controller, because as soon as I tried changing this dropdown, it crashes Unreal. I don't know why, but it does. So just be warned that it tends to do that. I don't know why. It's just the U class. I guess it should probably be a subclass of U class. I don't know, but it works. So there you have it. We have a constructor that I didn't use. I was originally going to do the targeting in the constructor, but I ended up realizing that for whatever reason doesn't work, because the constructor is running in the editor kind of in order to make this target struct inside of the object like it's sort of running the constructor. So it was just weird, and then in game it just didn't do any of the targeting stuff. So I put it in another function that we just call from the blueprint to do targeting. And I have another function that just sets my out actor array, even if I did a raycast, to make sure that I have an out actor array. So yeah, when I raycast, I just make sure like create my array of out actors, just so I can call the function that I made here to get out actors and always have something in it for just here's all the actors I hit. Even if it's a raycast, I'd only hit one. I just like that pattern. I like that sort of consistency. So when a designer goes in to like use this, you know, we don't want them to have to think about like, oh, I have to get the hit because it's a raycast, or I have to get the actors because it's a fear cast, because like, you know, that's not inherently obvious or like written anywhere, I guess. Anyway, so you can see my do targeting, all it does is switch on my targeting type and do a sphere overlap or do a line trace right here. But I just take in all of the targeting struct information. And that's all just set on my targeting object right here, and it's exposed on spawn. So we can see it's exposed on spawn, and I just make it right here. Kaboom. There it is. And then I call do targeting, and that do targeting is just that switch function right here. So it does the targeting, and then I get my out actors, which remember will always have data in them, even if we did a raycast. And then I'm trying to move to that actor. So if there's nothing here, if this is null, then our path following request result fails. Because it's like, well, I can't go to nothing. Or if you're already at the goal, it just means that, hey, I'm trying to move to this player actor, but I'm already within 5 units of being close enough to them. So, you know, try to hit them. And that's really where like range detection comes in, is actually the acceptance radius of this move to function. The other thing we try to do is we have to figure out, okay, the player is right here, but we can't get to them, right? So if we go, the player's here, but if we look at this guy down here, he can't get to the player. He has no way of getting there, because the AI by default can't jump. So like he can't get up on this block to come get me on this block. He doesn't know that he can jump and do that. He isn't very smart. So when we fail our move to, that's what's happening here, is he's failing move to, because he can't move to me. Even if he is finding me, which he might not be, except his radius might not be, or the search radius might not be large enough. But if we hit go to random location, so we failed our move to the player, we're gonna do a little bit of goal progression. And all I'm actually doing here is setting a point and making sure that I get close enough to that point before I change and do something else. So random point nearby. So this could definitely be, this is definitely 4 calls to almost the exact same functions. So it could be put into a function, simplified. It's just that I sort of, sometimes I write things out longhand when I do like AI decision making. I like to just write the function 4 times and then really go through it and figure out what did I change in each one of them? How can I do it? Can I just put a selector in and change my endpoints a little bit? Like, does that actually do enough for me to just run the same thing a few times? And like things like that, what can I make into a function and what do I have to keep specific to each piece of it? But we can go ahead and step through this. So when we look to one direction, we're looking 10,000 units. And what we're doing is we're looking for a wall that might be the end of the space we can go. So we're looking for anything that's in front of us. I can actually just have them draw it. So they're looking to the right. And they're just looking for a wall, right? And the reason they go 10,000 units is because they have to actually find a wall. So I've put walls, and I make sure that they are at least within 10,000 units of each other. Or 100,000 units, sorry. That's probably too much. I meant to do 10,000. That's where I put so I decided to design my levels at a 10,000 point grid, so that these guys are only searching 10,000 points in either direction at any given time. You can actually go to 20,000 before you have a problem. because they can search 10,000 in either direction, so you can go just under 20,000. And if you ask me, that's plenty for like a side-scroller level. 20,000 is probably about the size of a Dead Cells level. That's considered like, I consider those pretty big for a platformer, so that's, in my opinion, that's more than enough. Obviously, I could design something better that doesn't require hitting a wall, but you know, this is a simple, quick project. So if we do hit a wall, then what we do is we look down. So we hit a wall and then we look for the ground nearby. And if we can, play Egypt. So then we look for the ground nearby wherever we hit the wall. He's looking for a point that's on the nav mesh. And these guys are actually hitting this wall. And they're finding this point on the nav mesh down here. That's where they're casting. So if we don't find anything, then we try looking to the left. Now remember, this is also in parallel to, or this is also part of this function that's trying to move to it. When it tries to move to this location, it'll even try a partial path. So if it fails, it means I'm at the end of the space that I can walk in that direction, basically. So when I return it, I make sure, that's what this and is here, is that this point that I've calculated is not already my goal. Because if it's already my goal and I'm in this function, then I have kicked out from failed or already a goal. Right? I've kicked out this false. I've not been successful. I've been false. So I need to go back here and attempt to set a goal again. But if it's already the same goal, or if I didn't find any ground there, anything to target, then I'm going to go ahead and try looking to the left. And this is again the same sort of thing. We're just looking in the opposite direction, right? We can show these. And the difference here is that I didn't include that and statement because, well, we've already checked it for the right. We don't need to check it for the left. If it's already the same goal, then we have bigger problems because we didn't find a place we could go to the right. So you can see them going left, finding either me or the wall. So apparently I block enviro tracing. Not that it actually matters. Although really I shouldn't. That's strange. I really shouldn't actually. And you can see some of the magic of how some of the behind the scenes magic here is handled in the collision settings. So I've created a new object channel called AI Pawn and one called Character Pawn. This is really a player pawn. I created Character Pawn first and then realized like I really want to have them separate. So then I created a trace channel for damage tracing and enviro tracing. This damage tracing trace channel is the one that I trace for in my targeting objects. And then the character pawn by default does block enviro tracing. So if I go ahead and make that ignore, now you can see that they shouldn't target me. You know, it'd be real nice if these things worked. Well, that could also take a while to catch up. It could take a minute. I might also have things overwritten here. Well, it really doesn't look like it. Let's see. This is a character pawn. Well, that's weird. Let's see. There should be no collision. I suppose it could be these. It really shouldn't, because they shouldn't be generating any overlap events. And I don't think, yeah, they're gonna ignore enviro tracing anyway. They ignore everything that's not AI bonds. So that will probably fix when I relaunch the engine. That's gonna be my guess. The funny thing is, no, oh, now it's not happening. Oh, here we go. It did fix. Nope. Weird. Very weird. Anyway. So that is left and down. And that's all it's doing to path left and right. And it just, runs this every 0.2 seconds and determines, like, do I have a player to swing at? And if I do, swing and keep swinging. And if I don't, then, try to go left. If I can't, try to go right. So the other thing I do here is, let's see, in the shout, I did a different type of targeting. So I did a BP ranged AoE. This is still an attack base. So this still includes the attack collider code, the damage overlaps, and the extra movement block tag. This targeting object, the way that I've constructed it so far, is to just do targeting on a single instant happening. And in the code, I don't add a sphere collider, I actually just detect in a circle everything that's nearby. That's what sphere overlap actors does, is it's just like, I'm gonna create a sphere here and see what's overlapping it, see what's inside of it. Something else that I'm going to do down the road is I'm going to have an additional setting to do damage over time, or to have a casting time of an ability. Now this will actually create a targeting sphere that then lives for a few frames. It doesn't just happen all at once. And when I do that, I'm going to want more of an overlap, and I'm going to want to bind an event to it. And I kind of know that this is coming, but it's one that I haven't actually done yet. So you'll notice that this behaves a little weird when I cast it while the guy is too far away, and then he walks into it. I can't really, like that. Looks like he should have been damaged, but wasn't. That's the sort of thing that's going to be cleaned up by this. So I created this on the attack base because I know that I'm going to use the core of that functionality. So I went ahead and also included the damage overlap function here. Ooh. And in this class, I just override it and call the parent function. So the parent function calls an attack base. It's calling damage. It's saying do the damages. Right? But in this one, we're also applying knockback. So we're calling that knockback function as well. And looks like it's 500 laterally and 800 vertically. So that's why they keep jumping straight up. What we're doing is getting the other actor to owner actor. So we're drawing a line between the two of them, normalizing it and giving it a finite magnitude to make sure that we only push them so far. And there you have it. And the shout attack, as you might expect, just has setting some variables, I believe, yes. So it just sets some variables, how far away we're gonna project, what's the range, our damage, our shakes, our everything. Okay, so I just wanted to show off a little bit because this is pretty awesome in my opinion. I've made some pretty cool systems here, and I just wanted to kind of show you, like, here's what it looks like a week later when things start to get a little bit more hammered out and just a little bit more finite. Things need to be under a little bit more control. And obviously I've extended my hierarchy quite a bit. I've added a bunch more, more organization than anything. And I've added a little bit of code here and there just to continue to build out the remaining functionality to make a cool platformer game. So I hope this kind of rounds out the action object tutorial and kind of helps you understand what's going on with action objects and like how one would create more of them and things like that. You know, obviously, this is evade, which I didn't talk about. Evade is, you know, just a montage action, and all it does is it grabs a reference to the capsule component, which arguably we could put evasion in its own. We could cast to evasion, and we could give this capsule component on spawn, which is probably something that I'll do down the road, to be honest. And then in our basic class, we would just cast. In our basic class here, we would just say, oh, you're a montage action. Well, are you also an evade action? Monster evade. Oh, right, I've only made the one evasion. That's part of the problem. That's part of the reason that I haven't fixed that, is I just made the monster evade. I didn't actually make a solid evade. So this works as a pretty standard evade, in my opinion. So it ignores AI pawns. Now, it's important to note that this doesn't stop damage colliders, and that's a design choice. If you look, that's not always true, like in every game, but that's a design choice that I'm making, and that is that our AI actually has colliders that aren't pawns. They're AI hit colliders, right? So they're object type world dynamic. They're not object type AI pawn. So when you're evading, if they're swinging at you, they can still hit you. And that's a design choice, something that I like to have in this game. I'm probably going to have it ignore projectiles, but I believe for melee attacks, I still want them to hit you. So like if you're evading, but they happen to be swinging at exactly the right time, especially if you think about the attacks that we have and just how short those windows are as you're like trying to evade through them, like the odds of actually getting hit by that attack are pretty slim. I mean, I haven't gotten it to happen yet. Or else you'll see the screen shake, right? Oh, there's one. So it will happen. It's kind of hard to do. There we got one. There we go. I got hit right, yeah. So it happens. It's a design choice that I'm going to stick with. That's just me personally. But obviously you can see how that would be changed. Would be right here when we change this collision response, just added also to world dynamic, just ignore them as well, and then set them to block when you complete the action, right? Right, and I think that about covers everything, everything that I've made on this. I just feel bad with constantly being in tutorials and never seeing like what it looks like a week later when like I've actually chewed on it for a while. Like the gameplay ability system became Hero Dungeon Crawler, which you can look up on my website, in a matter of about a week, because I kind of take like this foundation that I make in these tutorials and I'm like, okay, let's start like figuring out what I'm going to do next, and then all of a sudden, bam, it's a game. And that's kind of where I wanted you to see like just how empowered you are using these systems to just bam, here's a game, and like really make something happen. So thanks for checking out this video. I know it's not really a tutorial, but I appreciate everyone for checking this out, and I hope to see you in the next series.